Good evening, everybody. Sean Carlson, Blackjack 98 Enterprises. Today is October 25th, 2023. This video is part 2 in understanding how to look at, adjust, and inspect overweight limit switch on a Betamaxial hoist. So let me turn around and show you my setup. Okay, so this is the mock version of the what you see in the back of your hoist. The switch is usually right in this direction. And I got this here to represent the rung that goes on top. And just before a lot of you are looking at me and say, Carlson, did you go and level that? Well, let's put a level on this. And you can see that it's somewhat level, not exactly perfectly level, but it's also not that much far off. Okay, so enough of that. Now, in the previous video that I had done, you seen me use this. Now, the only reason I use these is just so you can have an idea of that metal box that you see on your hoist. This represents the metal box, which I use as a plexiglass, and I went and made a tube out of 4 plexiglasses and taped them together so that way they're solid. They're also epoxied together. So when you look at the metal tube, this is what is behind it, the spring and the nut. That nut is held in place by either a tab or a knob. And what that, as you can see in that video, that tab or the knob makes the nut so it can spin when you're turning this. What this tube, the metal tube, also does is prevents anybody from taking a crescent wrench or a wrench and twisting that nut there. You're supposed to work on this nut, not that one, just this one. And we're going to look at the difference between this side and this side because they're both different, okay? This one has the exact same setup. It just does not have the tab like this one does, okay? So when you're turning it without a tab, as you can see, that nut turns when you turn this. See that? It turns. It's not supposed to do that. You can't put pressure onto that spring when that nut is turning, but you can do it with that tab there. So if we were to turn this, as you can see, look at that. See, that nut is turning. And if you continue to go in a tightening motion with this, that tab will press against the metal tubing, which will provide the force needed for that nut to go down and apply pressure to the spring. Okay, so this is the exact setup that you have in your Beta hoist. This can move freely up and down depending on the tension of that tab against it. Okay, but technically you can take a hammer, tap it lightly, and then you can sort of have an underneath view of the spring. Okay, so let's look at the science, because I got everything all written down here. Let's look at the science of how exactly this works. These 2 springs set the weight limit on the Betamax, and as I told you in my previous video, when you are applying tension to the spring, there's different levels of the different heights of the spring when you apply pressure on it. So 100 pounds will be like this, 200 pounds, 300 pounds, and so on. The more weight that you apply to the spring, the further down it goes, okay? So if you were to put a tension on here of 450 pounds onto the spring, it will go down probably about that much right there. And then what that means is, okay, I'm going to take this bar here. The hoist, let's say that this represents the hoist. Everything is fixed. This part here is part of the hoist. The spring is welded onto the hoist. Okay, yeah, let's want to talk about something else about that. You can unscrew this bolt completely out of this. Just unscrew it, loosen it, and the bolt will come out, and this will follow. You can like lift it up and then pull it out. The nut comes out too. The only thing that you will see is that spring attached to the hoist. It is welded in there, and you can look at that very carefully and you will see that. Okay, so according to the Betamax manual, you can set the weight limit on it. There is a procedure for doing that, and I will go through that later at a later date. But those 2 springs need to be adjusted equally, the same amount of turns to apply the same amount of pressure for both of them. Now, the switch on here will touch that knob right, the little thing on the switch will go As soon as you touch it, it'll shut the motor off, and then that is it. So what that means is when there is zero load on the hoist, it floats. Because there's an equilibrium balance between the motor and the carriage, this will generally float or touch the top bar here. And the minute you put a load onto the hoist, then that means the carriage is going down because of the weight, and because of the pulley is pulling the electrical motor up. And because this rung here is fixed ladder, it is going nowhere. The motor is going up and down, and when it lifts up, this is what happens. It sits nicely on both sides of them. And if they were unequally balanced, then you will see the motor either tilt a little bit, or there will be a noticeable gap. That will be your first indication that you have an uneven balance on those springs. Now, when you're going up or down with a load, this is technically what it will look like, but if you decide to suddenly stop when you're traveling up or down, then the motor will bounce and it will go up and down, and you'll hear it bouncing like that. When it's doing that, it might actually hit the springs to make it go down and touch that button. So if you're going in a downward motion and it starts to stutter on you, then that load is going to go bouncing up and down, which goes around on the pulley and pulls down on to this here part and lifts it up. Okay, and then this is bouncing up and down, touching that switch. So that was only the instance if you have a near overweight load and it is bouncing around on there. Now, hoist travels up once the load applies to the carriage. I just explained that. Because of it's like a seesaw, you put a load in the carriage, it pulls down on the pulley, which pulls up on the motor. Now, when the hoist is pressed against the rungs, like it is, like you see it right there, that is when it is traveling up or down with a load. A load will result in this. Now, if the hoist catches the pulley, or it hits the stop bar, or it hits an obstruction, and it is stuck when you're traveling up on the carriage, and you've got a load on it, and it goes all the way up and it hits something, making it stop, can't go up anymore, it's just stuck, like it's stuck. The hoist cannot go up anymore because there's an obstruction. It's either hitting the pulley, it's hitting the stop bar, or something sticking out is catching the scaffold, in which case is putting a huge tension between the motor and the pulley. And when that happens, the tension on the spool will set off the switch here, and it will be the exact same thing that will happen when you have an overweight. It will just suddenly stop. The bar here will hit the switch and it will turn off. Now, by compressing the springs when you are turning this here, you are increasing the load weight that is applied to the carriage. So if you're going to turn this once, turn this one once. If you're going to turn this again, turn this one just as much. Let's say 2 full rotations on this one, you're going to go on this one, 2 full rotations. Okay, you are compressing the spring, increasing the load that you want to apply to the carriage. Once you have exceeded that load, when you put it onto the carriage, this bar will go down and press against those bolts, which will press down on the spring. It will go down and it will touch that overweight limit switch, shutting off the motor. If you depress the springs by turning this the other way and loosening it, you are depressing the springs, which will result in possible suicide or attempted murder of innocent bystanders. The bolts should never be considered to apply tension to the rungs. Now, there is a little flap up here that there's a little C channel that which looks like that. It goes around here. I just wasn't able to do that. And if you were to thinking that you can tighten these up, this bolt will travel up and trap it against the top rung and here and totally secure it, you are absolutely wrong, because you will be turning this, tightening it forever, and all you're doing is you're just compressing the spring. Okay, if you are attempting that action, it will default the spring tension for the load lines and have unequal balance to the spring, and you will have disastrous results because you are intentionally misusing the hoist, causing there to be excessive tension on the wire rope and the pulley, and therefore you will have damage. Okay, so ladies and gentlemen, that is the explanation that I have with regards to understanding the load limit with my new improved mock version of the Betamax hoist. My name is Sean Carlson from Blackjack 98 Enterprises. I hope you enjoyed this video. Like, subscribe, comment, and do whatever it is you want to this video. I highly encourage it. Vancouver, British Columbia, Canada. Have a good day.